Okay, well let's start on 8.2 and 3, and I'll tell you, in 8.1 I did some stuff by hand, and then I was like, oh, now I can show you the easy part of it. Well, in 8.2 we go straight to the calculator. We're going to use technology now, so we don't have to really go into the harder aspects of developing confidence intervals. But the difference in 8.2 compared to 8.1 is that we won't know our population standard deviation. So in 8.2, we will not know the population standard deviation. So if you know the population standard deviation, you can do the intervals like we did in section 8.1. If you do not, we have to use a different technique. And we actually use a different distribution that's very similar to Z, but it's called the T distribution. And it has a neat background distribution. And I don't remember it exactly, but it was developed by the person's name was Student T because he wanted to remain anonymous. But what he realized, he was working at a brewery, and he noticed in the real world, the real world data didn't line up on the Z distribution. So let's say I've got the Z distribution that looks like this. Something like that. Okay, we've got this nice Z distribution. Again, it's still centered at mu, and T will be centered there somewhere as well. But what he realized with the T distribution in the real world, it doesn't spike up as high, so it looks a little lower like this. Real world data just kind of looked more like this when we didn't know the actual application. So this would be the T distribution. And it's based on degrees of freedom, okay? And if you have a higher degree of freedom, you can get closer to mu, because the degree of freedom is just your population minus 1. Let's write that down. Degree of freedom. We might have talked about degrees of freedom in here. I can't remember. But degree of freedom is always your sample size minus 1. Because if you think about it, if I'm trying to find the average of, like, let's say 5 test scores, in a weird way, the very last test score determines the average, right? If I know that the first test score is 6 and the next one's 7 and the next one's 6 and the next one's 7, well, I know the first 4, right? Well, whatever the last one is really determines what the overall average. And I know what you're thinking. You're saying, well, the first 4 did as well. And you're not wrong. But as you're adding them along, those are summing up. So therefore, those are already known. So whenever we get to the very last one, that's what determines what winds up being the final average. You don't have to know that. It's just a lot of times I get that question, like, where in the world does that come from? And it's really because the last term or the last value in the set determines everything, which is kind of neat. So anyway, let's get back to this. So if you have a really high degree of freedom, it means your sample size is really high. So that means that you do get closer to like the Z distribution. So it creates a tighter net. Remember we talked about the net before? So if you have a higher degree of freedom, you can create a closer net for the same confidence interval, right? Let's draw. Let me draw some more. Hopefully this will help a little bit. Usually visuals help with this example. We're kind of getting it. Okay. Now we're going to talk about lining up on X bar. Okay. We're going to talk about lining up on X bar. And actually it's going to be 0 for the T. But let's say I have a really steep T distribution. We're going to say that the purple, has a degree of freedom. We usually use DF of, let's say, 100. Okay, that's a really nice degree of freedom. So that means our sample size was 101, right? Now, if I had, let's use blue here. if I had a smaller degree of freedom for blue, let's say like 50. Now, this isn't perfect, it's just a visual. What that means is that I'm not going to have as much data centered around the X bar, the mean. So it's going to create a wider distribution. Okay? It's going to create a wider distribution. And when that happens, let's say I want to get, let's say I'm looking at 95% confidence interval. So I want a 95% chance of catching this mu, right? Well, 95% of our data here, I mean, it might be from here to here, right? For that purple. Because I have so much data centered around the X bar, this could be 95% of my data, right? But that in that same, for that same example, for 95%, we're going to have to widen it a little bit. So that could be 95% of my blue, my degrees of freedom of 50. So if I have a lower sample size, my 95 degree, my confidence interval is going to be a little wider than if I had a higher sample size, where it'll be a little smaller. Okay. And it's because I'm just more confident of catching these with a higher sample size. Okay. I'm more confident in catching these with a higher sample size. I'm not too worried that you understand that. This is a good like understanding on the test. Hey, explain what we can assume with a higher sample size. Oh, we can assume we can have our confidence intervals can be closer together because we have a higher sample size. So if we have a 95 degree or 95% confidence interval, it'll be not as wide as the same sample with a higher sample size. So that's a horrible way of wording that. I don't know why I'm kind of stumbling over my words.
It's Monday.
It is Monday. That marker just doesn't show up. Okay. Yeah. The other thing your book goes over is that n has to be greater than 30. So we have to have a simple random sample. Either the sample size is larger than 30 or the population is approximately normal. So n has to be greater than 30 or we have to come from a normal population. Okay. So if we know the population is normal, we're good to go. Or if we're greater than 30, if our sample size is greater than 30, we're good to go. Okay. And we'll see both of those. I'm not too worried about that. You'll see it as we're going along. Okay. And this is where I'm going to differ from the book. And we're going to go straight to the calculator on how to find these confidence intervals. Okay. I want you to look at page 381. And it gives an example here. Actually, yeah, we'll do the other example first. We're kind of going to do these out of order. But on page 381, I'm going to read the example. I'm going to pull out what we need to know to make this confidence interval. So this is example 8.13. It says the General Social Survey is a survey of opinions and lifestyles of U.S. adults conducted by the National Opinion Research Center at the University of Chicago. A sample of 123 was taken. 123 people aged 18 to 22 reported the number of hours they spent on the internet in an average week. The sample mean was 8.20 hours with a sample standard deviation. Now that's what's important. It's a sample standard deviation, so it's not sigma, it's actually S, okay? It's a sample standard deviation of 9.84 hours. Okay. Assume this is a simple random sample from a population of people aged 18 to 22 in the U.S. Construct a 95% confidence interval. From you, the population mean number of hours. Okay, yeah, great. So let's do this, and we're going to use the calculator. But I need you to notice for this example in 8.2, We don't have the population standard deviation. We have the sample standard deviation. And because of that, we have to use the t-distribution. Distribution. I don't know why I'm doing uppercase and lowercase, but it's a t-distribution. So when we pop this into the calculator, let's see if I can get this a little bit. I'm going to go into, what's it, stat? Yeah, stat tests, and you'll see t interval, number 8. So stat tests, the number 8 is going to be t interval. And it's a t interval because we're basing it off the t distribution and not the z distribution. And now I'm going to go over to stats, but we're going to do one with the data set here in a minute, but I'm going to go over to stats. It's not already there. Nope, it's not. Okay, well, I can start here. My n is 123. The x bar is 8.20. And notice it asks us for SX. That's the standard deviation, okay? The standard deviation is 9.84. And our confidence level, they asked for 95, and it's already in there, so 0.95. Remember, it's written as a decimal. Lori, let me know when you got that.
My calculator is different than yours.
How's it different?
On the T interval has input, there's data and stats.
Yep.
Next is the X bar.
Okay.
Then the SX.
Yep.
Okay. And
yep.
The C level and calculate. I think that's why it looks different because I can hardly see yours.
Oh, I'm sorry. Here you go.
No.
There we go.
Got it.
The same?
Okay. Yeah.
Okay.
Okay. So the X bar is going to be 8.20. What did you do?
Notice at the very top.
It knocked me out.
Oh no. I'm going to round these to 2 decimal places.
2. 3. Oh, okay. Yeah, I know why it knocked me out. On my others, I can just hit enter to keep going down, and this knocked me right out of it. If I hit enter, I got to hit the arrow. Yeah, weird. So it's 6.44 and 9.96.
Yes, ma'am.
Easy.
So now notice if you're looking at your book, they do this by hand in 8.13. And they wind up, if you look at step 4, they wind up with the mean, the population mean between 6.44 and 9.96. So you can do this by hand, mucho easier on the calculator, right? I mean, a lot easier. Now, this interprets the same way. Look, and this is what's important. We are 95% confident the population mean was it like hours on the internet for 18 to 22-year-olds is between 6.44 and 9.96. Okay, 6.44 and 9.96. So we're 95% confident. Oh, I didn't put confident. We are 95%. We're 95% confident. The population mean of hours on internet for 18 to 22-year-olds is between 6.44 and 9.96. Okay? Now, I want to show what I was telling you before. What happens when we kick up this n? Let's say they do this study. Let's say do the same exact study, and they get the same results, but they had a higher n value. Okay, instead of only surveying 123, they surveyed let's say 223. Why not? Okay, 223. And what we're going to notice, because we have a higher N value, we sampled more, we're going to be more confident about our results. So that means our width of our interval is going to become tighter. Okay, so all I did was change 223 or 123 to 223. Having to think. And notice the interval here. So I'm going to kind of do this one on the side. I'll use another color. I don't know if they'll even show it differently. So if n equals 223, the interval is 6.90 to 9.50, right? If you round. Notice that's, hey, that's pretty, I'm going to say it's a lot close, but that knocks off about one whole hour, right? You're about half an hour down from 9.96 and a half hour up from 9. So it's closer. Because we sampled more, we have a tighter width, right? So we're still 95% confident the population mean of hours on the internet for 18 to 22-year-olds is between, but instead of 6.44 to 9.96, it'd be 6.90 to 9.50 because we sampled more. Now, look, a lot of times you just can't sample more, right? You don't have the time, money, resources. People don't reply to surveys, whatever the reason is, okay? But it just doesn't happen, okay? Questions, comments, concerns?
Nope.
Making sense? It's nice not having to do this by hand, okay? It's really nice not having to do it by hand. You don't have to learn like how to use a chart. It really does make your life a lot easier. I should have done this by hand just so you could have seen it. Let's look at one where we have to actually put in the data. This is actually the sample right before it, 8.12 on page 380. It says a food chemist analyzed the calorie content for a popular type of chocolate cookie. Following are the numbers of calories in a sample of 8 cookies. So we've got a sample of 8. Find a 98% confidence interval for the mean. The number of calories in the, well, they checked for skewness, and yeah, there's no skewness. So we're just going to do this one. And to do this, we have to make a list. So let's remember how to make a list. It's been a minute before I've made a list. I think it's under stat. Edit.
It's under stat. Yeah.
Yes, stat and then edit. Edit. And we're going to edit just list 1 here. And we're going to put in these different cookie calories. So 113, 114, 111, 116, 115, 120, 118, and 116. Now look, if our data from our previous list was longer, you're going to have to go through, like, let's say I had other data in here. Oh, excuse me. Don't put 0 there. You've got to delete it out, okay? You know what? Why is it not letting me delete it?
Hit the DEL.
Did hit delete. Why is it not deleting? Oh, there we go. There we go. Okay. Yeah, it took it a minute. Okay. Okay. So now we have our list. So now when we go back to, was it stat and then tests? And we go back to the T interval, because this is a sample, right? We do not know the population standard deviation, right? We just have a sample. So we go to T interval, hit enter, and notice now instead of stats, we need to go to data. So if we have a list, go to stats, so T interval, but now we're going to choose data. And notice it asks you for the list. Now we have list 1 already. If you hit
right,
there's a list button. If you hit second stat, you can change the list. Now we already had it in list 1, so
right,
list 1. Frequency is 1. Sea level. Now in this example, they wanted 98% confidence, so we're going to put in 0.98 for the confidence level. It's gonna take it a minute. And boom, it pops it out.
112.38.
Yeah, and they rounded to one decimal place for this one. I have no idea why, but
Because they're weird.
they are weird. They just decide what they want to do. 112.4 and 118.4. And notice it's the same thing they got on the top of page 381. It's the same exact thing they got. So now we know how to do this with a list of data and also with the statistics from the data, okay? Which is kind of nice. Now this means the same exact thing. So let me write out what this means. We are 98% confident the population mean for the calories in this cookie is between 112.4 and 118.4. Okay. Remember, it's not that 98% of the calories are between there. No, it's that we're 98% confident that the actual mean is between there somewhere, right? We're 98% confident the actual mean is between there. Okay, let's steal some from the homework. Let's do some of these from the homework, and then we'll interpret and see how they kind of ask them in the homework. This is, I'll do some even ones. Let's do.
To check your understanding.
No, we're going to start on number 17 actually, because your book goes over different things you would have to know for the chart. And then I'm going straight to the intervals because you're using your calculator. So it would be like number 18. Let's just make sure we've got this. Number 18. This is on page 385. It says a sample size of 44. Sample mean of 56.9. And a sample standard deviation of 9.1. It says construct a confidence interval for the population mean. Okay, so let's do this. Now look, this one we know the stats. We don't know the data. So if we go to stat, tests, remember T interval still because it's the sample population or sample standard deviation. We're going to do stats this time because we don't have the list of data, right?
Mm-hmm.
X bar is going to be 56.9. Not 56 point parentheses. 56.9. Sample standard deviation is 9.1. N is what, 44? Oh.
It's 44. N is 44.
What did I say?
0.4.
Oh, my bad. 44. Confidence level is 98, isn't it? Yeah. Is not. It wants a 98% confidence level. So we've already got that in there from the last one. So 0.98. Hit calculate. And we're going to do just one decimal place. So let's say 53.6 to 60.2. So we're 98% confident that the population mean for this group, this set of data, is between 53.6 and 60.2. Okay?
Mm-hmm.
Now, B says, it didn't ask for interpretation, so I'm not writing it down. You'll get you some interpretation in the homework. But B says, if the sample size were 30, would the confidence interval be narrower or wider? N equals 30. Is it going to be narrower or wider? What do you think, Lori?
I think it's going to be wider.
Why?
Or am I backwards?
No, you're right. It's wider.
Because the population is lower.
Yep.
Than the other population.
Yeah, the sample. Yeah, the sample's lower, right? And with a lower sample, you're going to have a wider interval to catch it. Yeah, that's exactly right. Great. Okay, that's 18.
And it's 52.81 and 61.
Did you do it?
Yeah, it comes up 52.81 and 60.99
So it's wider. Yeah,
or
it's
61.
wider. Not by
yeah.
a lot, because it's not like that sample's that much smaller. But yeah, it's definitely wider. Okay. Let's see here. I'm gonna steal a real world example one. Okay, this is I'm gonna try to do one with the list now. This is 30. This is eat your cereal.
I don't eat cereal.
Okay.
Well, I do once in a while.
It says
Dinner.
eat your cereal. Boxes of cereal are this is on page 386. Boxes of cereal are labeled as containing 14 ounces. Following are the weights in ounces of a sample of 12 boxes. Is it reasonable to assume that the population is approximately normal? It says construct a 98% confidence interval. That's weird that it asks us that question, but then it's not a question. And then B says the quality could. Okay, wait. So let's just answer the question. A says construct a 98% confidence interval. So this one we're going to have to put a list in, right? So I'm going to go to stat, edit. We'll do list. I'm going to do list 2 just to show you how if you wanted to call list 2. Okay. So list 2, and I'm going to make these 14.02, 13.97, 14.11. Got to make sure I don't get a single one of these wrong. It'll skew everything. So 14.12, 14.10, 14.02, 14.15, 13.97, 14.05, 14.04, 14.11, and last but not least, 14.12. I mean, you get one of these wrong, and it's going to mess the data up, right? So you just have to really kind of check yourself as you go to make sure that you put it in correctly. But that's my list. So now I'm going to go into the tests, stat, test, still T interval, because I don't know the population sample, right? Or population standard deviation. It's a sample standard deviation. I'm going to do data. Now, I have to change my list. Now, if you put it in list 1, you don't have to. I have to change my list, so I'm going to do second list, and then list 2. Is it 98%? It is 98%. It's weird that they're using 98% so much. I've never seen this many.
Just the ones you're picking.
Exactly. Yeah, apparently. Okay, so we wind up with, for A, 14.017 and 14.113.
I got 14.009, 14.113.
That's interesting. Go back. Maybe you made a really small, goofy entering answer, because this is the answer. In the book, that's what the answer is too.
Let me check the list. Let me check my list and then check it twice. Does it really matter what order I put it in?
No, not at all.
I didn't think so. Okay.
Yeah.
1497, 14, 14, 1412. No, I've got all of them in there. Okay, and then stat test 8 data. Yeah, I still come up with 14.009.
That's weird. But the top number is 14.113?
Yeah, I have one. The first one is 14.009 and the second one is 14.113. Maybe you checked your list.
No, yeah. It's the same. That's what the book got, 14.017. That's goofy. We'll move on. We'll do another one and see if that happens again. It didn't happen last time, did it, Lori?
Uh-uh.
With the cookie?
No, and it's number 8 interval data.
Yeah, we'll check it with the next one. So,
minus-
but let's get to B. B says the quality control manager is concerned that the mean weight is actually less than 14 ounces. Based on the confidence interval, is there reasonable concern? Well, look, we're 98% confident that the actual mean is between 14.017 and 14.113. He doesn't have anything to be concerned about, right? I mean, that's a really good confidence. We're 98% confident that is between there somewhere. So no, he really shouldn't be worried about it being less than 14, right?
Mm-hmm.
Let's do another one with a list just to check. Let's do 32. 32 talks about mortgage rates following our interest rates for a 30-year fixed mortgage from a sample of lenders in Macon, Georgia on a recent day. It is reasonable to assume that the population is normally distributed. Good. So we're going to go to this list. Now, the list is on the top of page 387. So I'm going to go back to list. I'll make this list 3 for me. Oh, shoot. I did that wrong. Stat edit. And then I'm going to go over to list 3. And I'm going to put these in. So 4.75, 4.375.
Ha! Found it.
You did? Was it a small mistake?
Yeah, and I even looked over it twice and still got it wrong. There was one I evidently missed.
Oh, okay. Well, that makes sense then.
Yeah, I'm good at that. Okay, we're doing 32 now.
Yeah, and I'm just putting this list in.
Okay.
This list is on the top of page 387, number 32.
See if
Okay,
I
so
don't
I've got the
mess
list in, and it
see if I
says
don't mess this list up.
it says construct a 99% confidence interval. So 99% confidence interval. Okay, let's see here. So stat test. Now we're doing sample or T interval because we have a sample standard deviation. We're coming from the data. Now it's on list 3 for me. Remember, I put it in list 3. And it's going to be, I accidentally deleted list 3. And it's 99% confidence interval. So 4.119 and 5.525, or 4.525, I should say. 4.119 and 4.525. So that's the interval whenever you pop it into your calculator. That's the interval they got to. It says B, 1 week earlier, the mean rate was 4.050. A mortgage broker claims that the mean rate is now higher. Based on the confidence interval, is this a reasonable claim? Yes, totally reasonable. So if a week earlier, we were at 4.050. Notice it's not in the interval, right? It's lower than our lowest part of the 99%, or I should say our cutoff value, right? It's lower than our lowest cutoff value. So a week before it's at 4.050%, which is lower than our lowest cutoff interval. So yeah, definitely. We can assume that this is different, right? These are different because this would be, remember how we talked about those unusual events? This would be unusual. Look, only 1% of the time should our rates be outside of this interval, right? Because it's a 99% confidence. So only 1% of the time should our mean, I should say, should be outside of it. So if we wind up with a mean from the week earlier, 4.050, we can assume it's different because it's outside of this interval. So yes. Short answer, or long answer to a short answer, I should say. Okay.
Can't even spell.
That's about it. Yeah, so for homework for this section, I want you to start on 17. This is on page 386. Start on, or actually 85. Start on 17 and go through 43 and just do the odds. Okay, just do the odds. So this is section 8.4, 8.2. Good Lord, 8.2. Section 8.2, page 385. I know that's hard to read. Page 385, 17 through 43 odd. And the main thing is to understand how to put in the calculator. And then also, it'll go through some interpretation. So interpretation, and then, if it's a data set or if it's just the stats from the data set. Okay.
Okay.
Now we're going to go to 8.3, which is very similar, but it's with proportions. So confidence interval of population proportion. So the difference in this is we're not going to talk about X bar. It'll be like the amount in the sample that have the trait or don't have the trait, right? So it's found different. You are not going to have to do anything by hand on this one as well, which is nice. But I want to go over how to do this with an example. This is example 8.14 on page 390. It's example 8.14. Talks about music, and it says in a survey, so notice we've got 800 parents. In a survey of 800 parents, 632 said that music education has a positive effect on academic performance. Now, what's different is we're going to call this X. So we're not going to call it the mean. We're just going to call it X because your calculator calls it X, okay? And it says, for part A, construct a 95% confidence interval for the proportion of parents who believe that music education has a positive effect. So 95% confidence interval. So, and again, now this, we don't have a data set, right? So it's just stats. But if you go to stat tests, and you're going to see one proportion interval. Where am I not there yet? Yeah, there we go. So this is one dash proportion. We need the, I guess we can do the Z interval. Yeah, it's the Z interval. Should be. I feel like it should be the T interval, but that's fine. One proportion Z interval. We're going to click on that thing. What number was that? Hold on. Stat test one proportion Z interval. So it's A actually. So we click on that. Oh, I already did this example earlier just to make sure I got the right answer. But notice our X is 632 and our N is 800. And then the confidence level they asked for, actually they asked for a 95% confidence interval, don't they? So 0.95. They want a 95% confidence interval. Boom. And when you do that, you'll see you get 0.6 or 762 to 0.818. And that's exactly what they get. Like on the next page on their step 4 is 0.762 to 0.818. And so now remember, these are proportions. So it's saying we're 95% confident that the proportion of parents who believe that music education has a positive effect is between really 76.2% and 81.8%. Okay. It's about proportioning. So that these are percentage of parents, right? That believe that this education is important.
And actually going through the calculator, you're avoiding a few steps.
I'm avoiding a lot of steps. And
Yeah.
that's really why I feel like we can get to this, because what I feel is more important in this section, one, you're learning technology, which is fine, but also it's about interpretation. It's interpreting it that matters. In statistics, it's really about choosing the right statistical analysis. So for this one, it was, the proportion z-test, choosing that correctly, and then interpreting it correctly. Is there a B question? So B.
Since a value 0.80 is within confidence interval, the confidence interval does not contradict the claim.
Yeah. So the B, let's go back to the question. It says a music teacher claims that 80% of parents believe that music education has a positive effect. Well, because 80% in this interval, we can assume that that does not contradict what she is saying, or he, right?
Mhm.
So no, it does not contradict. Because 80% is in was it a 95% interval?
Yeah.
We'll say 95% confidence interval, okay?
And that's because it's in between.
Exactly. You notice it's, this is really 76.2% and 81.8%, right? So when she claimed it was 80%, boom, it's right in that interval, so it's not contradicting it. So if someone else said, no, I think it's 77%, they're not contradicting the findings either, right? Because we believe that, or we're 95% confident that it's somewhere in between, right? It's somewhere in between. I'm not going to worry about you guys finding, the sample size for this. That's not a big deal. I just want you to find these confidence intervals. The homework won't be that big for this one. Hold on. Yeah. Let's find another one in here and try it. So let's say we've got. Oh, it's my last piece of. Well, no, never mind. Okay, move that on my last piece of paper. Okay, 24, because this asks a few more questions. They kind of bring up the proportion stuff. So 24 says a college admissions officer sampled 120 entering freshmen and found that 42 of them scored more than 550 on the ACT. So we're going to say X equals 42. A, find a point estimate for the proportion of all entering freshmen at this college who scored more than 550. Well, you're just going to divide 42 divided by 120, and you wind up with 35. So 42 divided by 120 would be 0.350. So that would be a point estimate. It doesn't tell us a lot, but that would be a point estimate, right? 35% of entering freshmen score above a 550 on the SAT. Okay, that's all that's saying. B, construct a 98% confidence interval. For the proportion of all entering freshmen at the, So same thing. So now we're going to run that Z proportion test. So stat tests A. Now it was 120. Oh, no. Our X value is 42.
X is
right?
42.
42.
N is 120.
120, exactly. Now they want 98%, so 0.98.
0.250, I guess.
Yeah, let's do 49.
49.
Your book, for some reason, runs to 3 decimal places now. So 0.429 and 0.451.
Book doesn't want to change anything.
Yeah, it's weird.
They want to keep you confused.
Yes. So C states, so we've got the interval. C states, according to the College Board, 39% of all students who took the math SAT in 2009 scored more than 550. The admissions officer believes that the proportion at her university is also 39%. Does the confidence interval contradict her belief? What do you think?
No, it doesn't.
No, why?
It doesn't contradict because 39% is in between.
Exactly. Well,
The
you're getting this.
percentage.
Yeah. 39% is right there in between somewhere, right? So it's
Yeah.
not contradicting the findings. It is definitely not contradicting it. Now, her sample was below it, right? But when we attach the confidence interval, it's somewhere in between there. So it's not contradicting. Exactly. This is good stuff. Okay. So for this one, I just want you to do, it's not going to be that many. 11, it starts with kind of basic stuff. What is it? Wait. 15 through 25 odd. And I'm gonna bounce around a little bit. So this is page 398, 15 through 29 odd. And then I'm gonna bounce around because it brings up stuff that I'm not worried about. No, wait, not 29. I'm sorry. 25. 15 through 25 odd. And then 31 and 33. Okay, 31 and 33. So for page 398 and 399, this is section 8.3, 15 through 25 and odd, and then 31 and 33. So not a lot of homework. And these two sections are pretty similar. It's just different buttons you press in the calculator.